Welcome. In this episode, we're going to discuss about the use case modeling. So, the use case modeling directly originates from the functional requirement. If you understand the functional requirement very well, you will have a good use case modeling. In this use case modeling, we'll discuss about what is the use case diagram is, what are the components of use case diagram, and how we're going to draw the use case diagram. So, please like, share, subscribe, and leave your comment if you need more about the fundamental concepts of software engineering. Let's dive into use case diagram. So, use case diagram, this kind of diagram is related with the behavioral aspects or the behavioral diagram, and it represents both the structural and behavioral aspects of the system. So the use case diagram will represent the functionality of the system from the user's point of view. There are users outside the system's function, so they can understand or they can know what kind of system functionality have in a certain system will be represented by this functional this use case diagram. So the use case diagram has four fundamental components: the actor, the use case, the system boundary, the relationship. It could be generalization, include dependency, extend dependency, and association. Basically, there are dependency relationship in the use case diagram, and there is association relationship, and there is also the generalization relationship in use case diagram. For example, here we have the external, here you have the users of the system. Yeah. So they see the users looks like the system or the online shopping that have these functions. Yeah. For example, the view items, make purchase, and complete checkout and login are already the functionality of this online shopping. So the user or the actors will understand the system will perform such kinds of functions. Let's see the component of use case one by one. The first component that we are going to discuss is about an actor. An actor is already a person or a user who can initiate the use cases. So every actor, the role of every actor in a use case diagramming or use case diagram is to initiate a use case, whether it is a reactionary or actionary actors. So they will initiate the certain functionality of the use case. An actor in this context will be represented by the sticky man. So the sticky man is the symbol of actor in use case diagram, and the actor will have its own name. For example, if the actor is a student, so we can write just like this sticky man plus we have student. Yeah, we have student. This is the primary notation of an actor. So actor primarily can be represented by this sticky man. Not only this, the actor can be represented in the secondary notations. Secondary notation with the stereotype, or we have to write the stereotype. That is, we can write actor, yeah, the stereotype, and we have students, yeah. In this case, we can say the name of the actor is a student. So we can represent either of this. We can use the secondary notation or we can use the primary notations as the way. So actor is anything else that can initiate the use case or the functionality of the system. The other is the second component or the use case. Use cases already indicate the sequence of actions. Those sequence of action will have an observable result, or there will be a result after the end of those actions. So use case is one of the component in use case diagram. So it represents the functionality of the system as well. So actor will initiate the use case. So the use case will have a sequence of actions. This action will produce a result or the result. So an actor is symbolized or represented by this ellipse and the name of the actor. For example, we have these three functions of the system. For example, we can have save files is a kind of function. So at the end of the day, or it is a sequence of action. So finally, if you have a result, downloading a file is another kind of use case. So this use case will have its own sequence of actions, plus it is a result in writing a letter, also another kinds of use case. So use case simply a compound use case diagram, which means a sequence of action with observed results. The other component of an use case diagram is a system boundary. The system boundary is a demarcation point where the system functionality and the outside or the surrounding the system will be separated using the system boundary. So the system boundary is considered as the demarcation points, and the group of use cases will be placed inside the system boundary to indicate the system functionalities are there. So the system boundary represented by the rectangle. So this rectangle always represents the system boundary. So the system will have a name. The name will be placed at the top right corner of the system boundary, and various system functionality is already placed inside the system boundary. So simply this box is already the uh, symbol of the system boundary. So the system functionality is placed inside here in the system boundary, and the name of the system will be placed there. And the surroundings. So most of the surrounding is already the users of the system. So the interactions are from the environment. So the system will accept an input from the environment, or it will produce output for the environment. So this is the system surrounding environment. So uh, the system boundary also enables us, or it indicates us, it's a demarcation point where the system environment and its function is separated. It doesn't matter, you can draw the system boundary if you want, or you can leave as it is. So it's no mandatory to draw the system boundary. The third component the fourth component in use case diagram is the relationship. So there are different communications in use case diagram. The first thing, actor will communicate with the use case, or the use case will communicate another use case. So such kinds of mechanism will be represented by the relationships in a use case diagram. There are four fundamental relationships. The first one is an association between actor and use case. The second one is already the generalization relationship. That means it's a relation between the parent use case and the child use case. And the third one is already the included use case. In this case, one use case will explicitly take the another use case property, so it's also include use case. The other thing, one use case may take implicitly the property of the another use case, that is the extend use case. So there are four fundamental relationships in a CS diagram. We will discuss each one by one. This is this. The first relationship to discuss about is already the association. So when you say an association, mostly this kinds of relationship form between the use case and the actor. Yeah, we have an actor. Yeah, we have an actor. So the actor will associate with the use case, i.e., we have such kinds of we have an actor. So the actor will relate certain use case. So means that every actors will relate with yeah, so in a such a way, yeah, this is the use case. So this is the actor, the name of the actor we have represented here, and this is the use case name. So this use case name will be related with the actor of a certain or a particular system. So most of the time the association is related with the actor and the use cases. It is a relation between the actor and the use case of the system. Every actor will initiate the function of the system, or it will reply for initiated function by another actor. For example, we have a system which is called a banking system, and also we have two actors, the user and the bank app. So these two actors will initiate the use case. So this relationship is already an association relationship. For example, here we have two use cases, the make payment and the check for sufficient fund. So these are two use cases or functionalities of the system which is placed inside the system boundary. But the actor can initiate each use case. For example, the user will initiate the make payment. So this relationship already an association. The other the bank app will be initiate the check for sufficient fund. This is another association. So Such kinds of relationship between the use case and the actor are represented by the simple association. The second types of your relationship is already included use case. So in this case, there is two use cases. One use case is dependent with the other, or that means as one use case will wait the result of the other use case. So bring the complex and redundant system to minimize those particular redundancy and complexity. So we will use the included use case. So include use case is easier to solve redundancy and complexity. Assume the system in complex system use case modeling can be become complex, and also it contains redundancy or redundant representation of the use case relationship or the use case drawing. At this time, we can minimize also redundancy and complexity using the included use case. So include use cases to solve redundancy and complexity. One use case explicitly includes the behavior of another use case at the specified point of time with the cursor action. So the the include use case does not have it doesn't stand alone character key, so it will exist with another use cases. So it has most connected with one or more basis cases. So always the include case connected with the what you call the basis cases. For example, we can represent it in such a way. So this include use case always related with the basis case. So this include case it doesn't exist alone by itself, but it is we will have another use cases or the basis cases. For example, here we have two use cases, the login use case and the verify use case. The verify use case does not exist by itself, rather it will be related with the login use case. So what does mean here? Before processing, before logging to the system, or the password must be verified. So this is mandatory, yeah. So unless and otherwise, if the verified password is failed, the login also failed. If the verified password is successful, the login also successful for all users can all users login must be depend on the verified password. So every login will depends on the verified password. So you can say this login is the basis case, the verified password is the include use case. So this basis case will take the properties of this include use case property explicitly. The other thing we can say that, so we have two use cases here, the login use case and that are to wish list and checkout use cases. So the checkout, the add to wish list use cases are the two base use cases. These are the base use cases. Yeah, these are the base use cases. But to check out and to add to the wish list, it with this property. This is the include use case. Yeah, this is the include use case. That is, unless and otherwise, these users login into the system, they cannot check out whatever they want, and they cannot also add anything else about to their wish list. So this is what we call unincluded use case is mean. The other types of relationships also extend this case. So this extend this case also enables us to minimize complexity and redundancy as we did in included use case. So these are an alternative means of for reducing complexity in the use case model. We have here also two use cases, the basis case as well as the extended use case. So the basis case takes the properties of the extension or the extended case implicitly. This point also called an extension point. In extended relationship, there should be one particular condition. There is a certain condition, unless and otherwise, this relationship cannot exist. So extended relationship constructs two factors out behavior that is optional or that occurs only under certain conditions. So there must be a certain condition to occur for the occurrence of extended relationship or this extension point. Let's see, we have these two use cases, the extended use case and the basis case. So the basis case, or that means this basis case will take the properties of the extended use case implicitly. Yeah, this basis case will take the properties of this. Such kinds of mechanism also called unextended use cases. For example, here we have both, we will represent both the include and the extend use cases. For example, assume we have user A, user B, user C, and user D. So we'll have here an actor. Yeah, it is also called user. So each user will log into the system. For example, A will be logged into the system, B will log into the system, C also logged into the system. So every login will be verified. The password verification is mandatory. Yeah, there is no optional. If A is logged into the system, the password must be verified. The same is to B and C and D. So this is an include use case. So include use case is already a mandatory use case. A mandatory use case. Whereas in the extend use case, it is an optional. Yeah, it's an optional. For example, both A, B, C, D will log in into the system, but unfortunately D will be make a mistake. Yeah, D will be made a mistake. So A is logged successfully, C is logged successfully, and A is and B is also logged successfully. But suddenly user D will produce an error. So this is, there is an extension for, there is a special condition, because the condition is user A produce a certain error. So at this time, this use case will be activated, because what, there is a condition. It's no mandatory, it's not optional, it's no work for ABC. Yeah, because ABC are not producing any error when they log into the system. Maybe they insert their credential username and their password correctly. Maybe A will miss his name, or maybe his password, so error will be produced. So to, in this case, we can say extend use case is an optional relationship. So this is what the extend use case looks like. The other is already the generalization use case. When we say the generalization, it is the parent and child relationship among the use cases. So in generalization works the same way for use cases as it does for the classes. A parent use case defines the behavior that's hidden, that its children can inherit. So here we have the abstract use case and the child use case. So the child use case will inherit some of the characteristics or the properties of it's his parent or the parent characters, but not the same as with the parent use case. So the children cannot or override the behavior of his parent. For example, we can represent this like this. So the parent's case already, it is an abstract use case, and the child's case is a specific use case. So such kinds of relationship already, the generalization relationship, it is a parent-child relationship in use case diagram. For example, let's see here, we have the book searching system. So the book system indicates that this is the parent, is the most generic use case, or abstractly represent some of the use cases. Yeah, this is abstract use case. This is or a parent. This is a parent. Yeah, this is parent use case. Yeah, the rest of search by title, search by title and author, and search by author are the child use case. So such kinds of relationship can be represented by the parent-child relationship. There is a commonality or a similarity between, but one use case is more abstract, the other use case is already more specific. So in such a way, we will represent the relationship in generalization use cases. So this is all about the component of use case diagram. So why we do, or what are the flows of the use case? So how the sequence of actions flow looks like. So in use case diagram, there are two fundamental flows of actions, or there are two flows or two paths. Two kinds of flows of events are associated with the use cases. These are the main flows of events or the exceptional flows of events. So the use case often has at least one exceptional flows of event. Example, let us see the login use case to consider main flows of event and exceptional flows of event. So don't forget that we have two flows of event. This is already the basic course of action. Yeah, the fundamental of this main flows of action, or also called the basic flows of action. So in this case, it is also called the sunny day scenario, the sunny day. scenario. Yeah, the sunny day scenario. Sorry, the sunny day scenario. That means there is no error. Yeah, there is no error produced by either the system or by the user. The user maybe insert their elements, then they will finish without any alternatives. So there is the main flow event or the CNI scenario. The exceptional flows of event or is also called an alternative course of action. So there should be an alternative path to follow the right of the main flows of event. We have two types of flows of event, the main flows of event as well as the exceptional flows of event. The use case often has at least one of exceptional flows as I before. Let's see, for example, let us see the login use case to consider main flows of event and exceptional flows of event. If it is in the main flows of event, for example, to login, the user will type their name and password. They initialize the login use case, then the system will redirect to the next use case. So this is the main flows of event. There is no error produced by the system as well as there is no error produced by the user. This is a normal flows of event, or this is the sunny day scenario. So the other flows, for example, the user will type username and password, initiate the login use case, but the system refuse. That means the system not will direct to the next use. Error will be happen or error is happening. So the user will need another alternative action to continue to flow the normal flows of event. So the user will take another options. Maybe the user may forget their password, so they will reset their password, or the user may have not user account, so they will create a user account and so on. So in these types of logs of event, there should be an alternative action to gain to follow the main flows of event. Unless in otherwise, there is no a way to continue or to finalize a certain use case actions. So this is already exceptional flows of event, or this is an alternative flows of event. Why we draw the use diagram. So the use case diagram, how draw use case diagram? Use case diagram are considered for high-level requirement analysis system. When the requirements system are analyzed, the functionality are captured in this case diagram. So if you know the functionality of the use case diagram, you can draw the use case diagram very easily. During the planning to draw the use case diagram, it should be identified the following items. So you have to identify what are the functionality of the system or functionalities to be represented as this case? Who are the actors to initiate each functionality of the system? Relationships among the use case and the actors. So we have identified the functionality. We will have the functional requirement. So we know that the functionality of the system is very easily. Also, we know also the actor from the business domain. Who are the users? Who are the users of the system? And who will initiate which function of the system. We have to define this. The other thing, there is a relationship dimensions that maybe it could be an association, it could be generalization, it could be extend or include use cases. So we have to identify such kinds of relationships. So if you know this, we can draw the use case easily. So this is a little bit all about the use case modeling. It's part one. We will continue in parts with a practical exercise.